A planet that receives a signal from deep space surpasses all expectations, and a competition to another star. What if everything we thought we knew about the universe is about to be shattered? The James Webb Space Telescope, JWST, has uncovered secrets so shocking that they could rewrite the rules of life as a whole. But is Proxima really a new Earth, or a deadly trap? The James Webb Space Telescope, often hailed as humanity's most advanced instrument in the sky, has recently turned its gaze toward one of the most intriguing exoplanets ever discovered, Proxima B. This distant world, orbiting the red dwarf star Proxima Centauri, has enthralled researchers, enthusiasts, and non-fans alike since its discovery. But now, with the unparalleled capabilities of the JWST, we have reached our goal, getting a closer look at this mysterious planet. And the revelations are nothing short of extraordinary. Proxima B was first detected in 2013, but it wasn't until the James Webb Space Telescope came into play that we could truly comprehend the contents of this distant world. The telescope's ability to capture images in the infrared allowed astronomers to peer into Proxima B's atmosphere, revealing previously hidden details. What they found has sparked both excitement and concern. You see, Proxima B orbits its star at an incredibly close distance, just 7.3 million kilometers away, which is less than 5% of the Earth-Sun distance. This proximity means the planet completes a full orbit in only 11.2 Earth days. But what makes Proxima even more fascinating is its host star, Proxima Centauri, a red dwarf. Contrary to our relatively stable Sun, red dwarfs are well known for their volatile nature, often emitting powerful flares that can drastically affect orbiting planets. Now here's where things get even more interesting. The JWST has provided the most precise view of Proxima B, and it has revealed some startling features. For one, the planet is about 30% larger than Earth, indicating a stronger gravitational pull. But what's truly shocking is the possibility that Proxima B is tidally locked to its star. This means one side of the planet is constantly illuminated, while the other remains shrouded in eternal darkness. Imagine a world where the sun never sets on one side, and the other is thrown into an endless night. This tidal lock produces a harsh environment. The side facing Proxima Centauri would be scorched by constant radiation, while the dark side would remain a frozen wasteland. This raises a critical question: could life ever survive in such extreme conditions? The possibility seems slim, but nature often surprises us. But the difficulties don't end there. Proxima Centauri itself poses a significant danger to habitability. The JWST has shown that the star is much more energetic than previously believed. Its potent magnetic fields produce intense solar flares that bombard Proxima B with high-energy radiation. In fact, a flare observed in April 2021 was 100 times more powerful than any flare ever seen from our Sun. Such enormous surges of energy could strip away the planet's atmosphere, exposing it to the abrasiveness of space. According to some researchers, the frequent proximity to its star and the constant solar flares make it unlikely to support life as we know it. Others, however, suggest that life might find a way, adapting to these extreme conditions. Could there be organisms on Proxima B that have evolved to survive in such a volatile environment? Or is the planet doomed to remain an isolated rock without life? As we continue to explore Proxima B with the James Webb Space Telescope, more secrets are certain to be uncovered. One thing is clear: this tiny planet, just 4.2 light-years away, is far more complex and enigmatic than we ever imagined. Could it be that Proxima holds the key to understanding the limits of life in the universe? And if so, what does that mean for our search for extraterrestrial life? Proxima B's stunning secrets were revealed in what was one of the most shocking discoveries: its atmosphere, or more specifically, the potential lack thereof. The intense radiation from Proxima Centauri, combined with the planet's close orbit, means Proxima B is constantly bombarded with solar wind and high-energy particles. Over time, this relentless assault could have eliminated the planet's atmosphere, leaving it barren and exposed to the cold vacuum of space. But here's where things get interesting. Some scientists believe that Proxima B might still retain a thin atmosphere, possibly composed of heavier gases like carbon dioxide or nitrogen, which could provide some protection from the star's radiation. The James Webb Space Telescope has provided us the most detailed glimpse of Proxima B yet, and what it has revealed is both fascinating and mysterious. The planet's surface appears to be rocky, much like Earth, but with a key difference. The side of the planet facing Proxima Centauri is likely scorched, producing a desert-like landscape. Meanwhile, the dark side of the planet could be a frozen wasteland, with temperatures plummeting far below anything experienced on Earth. But the most intriguing possibility lies in the narrow strip of land between these two extremes, known as the Twilight Zone. This area, where day and night meet, may offer more temperate conditions where liquid water could exist. And liquid water, of course, is one of the key ingredients for life as we know it. Could this twilight zone harbor a hidden oasis, where life has managed to take root despite the harsh conditions? Another stunning revelation came when scientists examined the potential for Proxima B to contain water. If water exists on the planet, it would likely be in the form of ice on the dark side, or in small, temporary bodies in the twilight zone. But the discovery that shocked many was the potential for subsurface oceans, similar to those found on moons like Europa or Enceladus in our own solar system. These oceans could be warmed by the planet's core or by tidal forces caused by its close orbit to Proxima Centauri. If such oceans exist, they would be a prime location to search for life hidden beneath the planet's icy surface. And there's more. Proxima B's magnetic field is another factor that adds complexity to the environment. Recent research suggests that the magnetic field could interact with the planet's core, producing its own magnetic shield. This interaction might protect the planet's atmosphere from being completely stripped away by stellar winds, similar to how Earth's magnetic field protects us from solar radiation. However, the situation on Proxima B is far from straightforward. The star's powerful flares could still overwhelm the planet's defenses, leading to abrupt and dramatic shifts in climate and surface conditions. These discoveries raise more questions than answers. Does Proxima B have a strong magnetic field? How does it impact the planet's atmosphere and potential for life? Could life on Proxima B have evolved to survive such fluctuating, extreme conditions? If life does exist, what form would it take? Would it be something entirely different from anything we've seen on Earth? Or could it share similarities with extremophiles, organisms that thrive in Earth's most inhospitable environments? Proxima B is a hostile world where life would face extreme challenges. Yet, in the vast and unpredictable universe, where nature defies expectations time and again, perhaps this rocky exoplanet holds more surprises than we ever dared imagine. As new data streams in from the James Webb Space Telescope and other observatories, our understanding of Proxima B continues to evolve. Each revelation deepens the mystery, painting a picture of a world that defies easy classification. Scientists are now turning their attention to the chemical composition of Proxima B's atmosphere, if it exists at all. Trace gases such as methane, ozone, or water vapor could offer the first tangible signs of biological processes. These biosignatures, while not definitive proof of life, would be compelling evidence that something unusual is happening on this distant world. But the search is delicate. The intense radiation from Proxima Centauri makes it difficult to obtain clear, stable readings. Every attempt to measure the atmosphere is like trying to hear a whisper in a thunderstorm. Yet, thanks to the JWST's infrared capabilities, scientists are able to isolate wavelengths that were previously drowned out by cosmic noise. Then there's the question of geological activity. Is Proxima B geologically dead, or does it have an active interior? Volcanic activity could release gases into the atmosphere, helping to sustain it against solar winds. In fact, recent thermal imaging hints at heat signatures that might indicate tectonic movements beneath the planet's surface, another potential ingredient for habitability. Even more tantalizing is the growing theory that subsurface life could be protected from surface radiation by layers of rock and ice. If Proxima B harbors underground oceans, as some suspect, they could provide a stable, warm environment, shielded from the deadly flares of its parent star. In such isolated pockets, life might not just survive, it might thrive. But for now, these remain educated guesses. Proxima B exists in a realm just out of reach, close enough to study but far too distant to touch. The idea of sending probes or crewed missions to Proxima Centauri, while exciting, is still a dream bound by current technological limits. A journey of 4.2 light-years would take tens of thousands of years with today's spacecraft. Concepts like light sails, fusion engines, or wormholes are still theoretical. And yet, hope persists. Projects like Breakthrough Starshot aim to send tiny, high-speed probes to nearby stars, including Proxima Centauri, within the coming decades. If successful, such missions could transmit actual images and data from Proxima B, giving us our first direct glimpse of an alien world up close. Until then, we continue to watch, to calculate, and to dream. The mystery of Proxima B is far from solved, but every new discovery brings us closer to answering one of humanity's oldest questions. Are we alone in the universe? And perhaps, just perhaps, Proxima B holds the first whispered reply. The idea of a planet in Proxima Centauri that is habitable is captivating. The reality, however, is far from accommodating. The James Webb Space Telescope has provided previously unheard-of insight into the difficulties that any potential life might face on Proxima B. The image shows Proxima B facing one of the most significant challenges: exposure to high radiation levels from Proxima Centauri. In contrast to our Sun, Proxima Centauri is a red dwarf star with a much smaller mass and a significantly more chaotic surface. Because this star is close to the planet, Proxima B is bombarded continuously with intense solar radiation, including powerful flares that can be 100 times stronger than those emitted by our Sun. These flares produce a deadly cocktail of ultraviolet and X-ray radiation that could kill any form of life similar to Earth's. The effects of this radiation are not merely speculative. In April 2021, an especially large flare from Proxima Centauri was detected. It was strong enough to possibly eliminate any atmosphere that might have existed on Proxima B. This event serves as a stark reminder of the dangers posed by red dwarf stars and raises questions about the likelihood of Proxima B being a haven for life. Moreover, the constant exposure to such radiation would transform Proxima's surface into an incredibly hostile environment. Any water on the surface would be quickly vaporized, and the planet's rocky terrain would be scorched by relentless heat. Even the planet's dark side, not directly exposed to radiation, would be equally inhospitable due to freezing temperatures. The stark distinction between the scorching day side and the bitterly cold night side leaves little room for stable life. Despite this, the competition to reach Proxima Centauri begins. While the signal from Proxima Centauri remains a mystery, the notion of actually getting to the star system is shifting from science fiction to real science. The Breakthrough Starshot Initiative, led by a group of visionary scientists and backed by prominent figures like Stephen Hawking and Yuri Milner, intends to send miniature laser-propelled vehicles to the Alpha Centauri system, including Proxima Centauri, within our lifetimes. The idea behind Breakthrough Starshot is as ambitious as it is revolutionary. The plan involves launching countless small spacecraft, each roughly the size of a postage stamp. These starships would be driven by powerful lasers, reaching speeds of up to 20% the speed of light. The objective is to launch the spacecraft on their decades-long journey to Proxima Centauri, from which they could retrieve data about the planets and star system, including Proxima B. Though the difficulties of such a mission are historic, the potential benefits are equally numerous. Discovering the true nature of Proxima B, whether it is barren or a life-harboring world, could have significant repercussions for our understanding of life in the universe. What if Proxima B brought life to the universe? This strange and volatile world holds the key to understanding life in the cosmos. The hunt for extraterrestrial life is one of humanity's most profound quests. But as we learn more about Proxima B and other distant worlds, we are forced to confront the realization that life may not unfold as planned. In the end, Proxima B may not be the Earth-like paradise we imagined. But it may be a vital stepping stone in our pursuit of knowledge about the universe. The search for life in the universe is only just beginning, and Proxima B is leading the way. But the question remains, will we ever be able to uncover its secrets? Only time, and ongoing exploration by instruments like the James Webb Space Telescope and projects like Breakthrough Starshot, will tell. Perhaps Proxima B is not just a planet to be studied, but a glimpse of our future. The search for signs of life, whether in our own solar system or on distant exoplanets, is a reflection of humanity's innate curiosity and desire to understand the cosmos. Discoveries made about Proxima B could shape the next generation of space exploration, giving important insights into the potential for life on distant worlds. Even if Proxima proves to be hostile to life as we know it, the lessons we learn from this exoplanet may have significant implications for other planets out there. We may one day find worlds that are more hospitable, more like our own Earth, where life has discovered how to thrive and survive in the most difficult of environments. The quest for knowledge will keep going. As we press the boundaries of space exploration, we will no doubt solve additional mysteries that challenge our understanding of the universe. In the end, Proxima B serves as both a symbol of the challenges we face in exploring distant worlds and a reminder of the incredible possibilities beyond. It lies as a planet that might or might not harbor life, but its significance lies in the questions it raises and the journey it inspires. Through continued advancements in space technology and the use of tools like the James Webb Space Telescope, we are closer than ever before to answering one of humanity's most profound questions: are we alone in the universe? The search for life may one day lead us to Proxima B, or perhaps even further into the depths of space. And if we find life, whether microbial or something entirely different, we will have taken a monumental step in understanding the vast, mysterious cosmos, the majority of which we have just begun to investigate. Regardless of the outcome, Proxima B will continue to be a touchstone for our ambitions, inspiring the next phase of research, science, and exploration for future generations. As we advance deeper into the space age, each discovery acts like a breadcrumb, guiding humanity along a cosmic trail. Proxima B, despite its harsh conditions, remains one of the most compelling markers on this path. Its extremes challenge our assumptions, forcing scientists to redefine the parameters of habitability. Could life, if not as we know it, exist under conditions so radically different from Earth's? This question has driven the development of new models in astrobiology, ones that account for exotic chemistries, resilient extremophiles, and entirely novel ecosystems. The idea that life requires Earth-like conditions is slowly giving way to a broader understanding, one where life might adapt, evolve, and flourish in ways we have yet to imagine. Beyond the science, Proxima B also carries a symbolic weight. It reminds us of how far we've come since we first looked up at the stars and wondered what lay beyond. What was once myth and speculation is now observation and data. We are no longer passive dreamers, we are explorers equipped with telescopes, algorithms, and vision. And this journey isn't just about finding life. It's about understanding our place in the universe. Each mission launched, each signal analyzed, is a testament to humanity's desire to connect with something greater, to reach across the void and find meaning among the stars. In that sense, Proxima B is more than a destination, it is a mirror. In its light, we see our future, a future where interstellar travel, planetary colonization, and galactic exploration are not only possible but inevitable. The road will be long and uncertain, marked by failures and unexpected discoveries. But it will be paved with wonder. If we are to make Proxima B more than a distant dream, we must continue investing in our science, our technology, and our shared hope. Each generation must carry the torch forward, daring to ask impossible questions, and daring even more to find the answers. Because somewhere out there, on a rocky world orbiting a dim red sun, the universe may be waiting to greet us, not just with answers, but with the next chapter of our story.